So this is a standard Hallmaster ball hitch. This is what our group decided to redesign. It consists of 8 parts, and I will now disassemble it in order to show you each of the 8 parts. So I'll go and talk about the parts individually. So first off, I'll go and start with the cotter pin. The cotter pin was most likely drawn, cut, and then forged. Then we'll go to the hitch pin. The hitch pin as well was probably drawn and cut, but then it also had to be machined in order to get this hole and this grinding down in order to make it easier to insert into the hole. And then it was also forged in order to get the shape. So the nut was most likely drawn, cut, forged, and then machined, and then after those processes were over, it was most likely then heat treated. The washer itself, as you can see here, it's pretty thick. It was most likely rolled and then punched in order to get it to its desired tolerances. The bushing is made of aluminum, and it was most likely extruded. So this is the main part of the hitch. It has the 2-inch square tubing, and then it also has a 3/4 inch steel plate ankle. To start, we'll describe the tubing itself here. The tubing was most likely hot rolled through several die in order to achieve the square shape. And then, if you can see it inside of the square tubing, it was seam welded in order to keep it together. And then after it was created, it was machined to gain the holes here and then the miter cut here in order to connect to the ankle. That leads us to the ankle. The ankle was most likely also hot rolled to gain its shape and then machined to cut out the hole for the ball and this rounded edge. And then after that, it was forged in order to get the desired angle. These 2 parts were then connected using a weldment seen here.
Our product consists of 3 main subassemblies, one being simply the hitch pin and cotter pin as seen here. The second being the main assembly, which is the ankle and square tubing, and the last being the ball and shank, which consists of a hex nut, a washer, a bushing, and the ball and shank itself.
The overview of the DFA is that with our final design, we pretty much decreased the handling and insertion metrics on the DFA analysis, and that was through the pin or the chain connecting the cotter pin and the hitch pin, and then also through the handling of inserting the hitch pin into the hitch. And so we decreased those 2 metrics, but in the end, the secondary ops actually increased due to having to do some more welding and some more grinding as well. So that's the analysis of the DFA.
All right, so this is our new and improved ball hitch. There are 3 key changes we made to improve the overall design. Firstly, we added a chain connecting the hitch pin to the cotter pin to prevent losing either one. And then we also added a 1-inch round tubing on the inside of this square tubing here to make it easier to slide the hitch pin through, and you don't have to fondle around with the hitch pin to find the other side of the hole when you're attaching the hitch. And then we also changed the degree of the ankle here from 60 degrees to 45 degrees based on a simple statics analysis, because we found that the horizontal load would tend to be greater than the vertical load, and because of that we decreased the angle because welds tend to fail in tension rather than in shear, so this makes it a little more safer. There are a couple key new manufacturing processes required to make our new design part. Firstly, a larger hole would need to be drilled into the side of this square tubing to allow for this 1-inch round tubing to fit in here, and then the round tubing would also need to be welded into place, and then the excess would have to be machined off afterwards. And then additionally, the chain between the hitch pin and the cotter pin would have to be welded in place as well.
Now we're going to go demonstrate the functionality of our newly designed ball hitch.
As you can see from the video, our functional prototype worked great when tested with a trailer. Thanks again for watching. See you next time.